Okay, so we're going to work together through the sample problem on page 639, sample problem 17b. This is ugly, this is horrible, this is awful. Your assignment then will be number 1 on page 639 in the practice problems. Just number 1, that's all. Just number 1. That's your whole assignment. And I guess I have to put a due date up there sooner or later. But for now, let's work through the sample problem together. Okay? Because we're looking for the resultant, we're going to have to calculate the forces from on Q3 from Q1 and on Q3 from Q2. We'll then break those up into their components. We'll then do a total X, total Y, use Pythagoras, get a resultant, and get an angle. It's not that hard, it just looks awful.
You made it sound pretty.
Well, it's relatively awful actually, yeah. Okay. So the charges are given in the problem, and we're looking at the radius between Q1 and Q2, so 5 meters, and that is squared. The charges are all given in the problem, the distances and arrangements are all given in the problem. You're really just plugging in, which is not terrible. Button here. Okay, so we've taken our absolute magnitudes of the forces between them. We've gotten the x components of the force of 3, the force on 3 from 2, and that was the whole magnitude of the force. And we used trig to get the x component of the force on 3 from 1. So now we have our x's set aside. Now let's work with our y's. That one's easy. So the force on 3 from 2, y component is 0. Hallelujah, we got something easy. Now let's use trig to find the y component of the force on 3 from 1. Okay, so we've got force, the total y, and we've got both of our x's, so now we're going to get our resultant y and our resultant x so that we can move on to the last step. Whew. Okay, so now we've got our total x force is 2.99692 times 10 to the negative 9th newtons. We can now take our resultant x and our resultant y, so this number, and do Pythagoras. And this one is heading in this direction, so we have that, and we want this. That's our resultant. And we need that angle. So we're going to run out of time here. I'll let you do that. The sample problem is in the book. You should get a resultant force of 7.16 times 10 to the negative 9th newtons and a theta of 65.2 degrees. The numbers in the book will be a little bit different because, of course, they do the horrible thing with rounding at each step. We know better than that. We do better than that. And so we're going to get a more precise value for our final answer.